Welcome back. So our final problem in the two-pointer series asks us to imagine a list of integers as an elevation map. Each integer represents the height of a bar in the map. And so, for example, the list of 0, 1, 0, 2, 1, 0, 1, 3, 2, 1, 2, 1 has bars with heights of 0, 1, 0, and so forth. Our task is to return the amount of rainwater captured in the elevation map, where the amount of rainwater will be equal to the depth of any local minima found in the map. So, for example, there's a local minimum 0 in the neighborhood of 102, which has a depth of 1, and so 1 unit of rainwater will be captured. One naive approach might be to say, well, all that we really need to do is track how far down we go from a local maximum until we reach the next local maximum. And if we add the collected rainwater that we get from maximum to maximum, we should get the total amount of water. So this is mostly true, but there is a problem. What happens when there's a local minimum found from the right-hand side of the map? To see why this is an issue, let's go through the first case using only one pointer. So everything seems to be okay until we reach the neighborhood of 212. We fail to add the additional unit of rainwater because we haven't yet gone back up to 3, our current local maximum. This approach, therefore, is incorrect. So let's instead try this problem out using a two-pointer approach. Placing a pointer on either end, we will set the left max height and the right max height to be the left and right ends of our list, respectively. Next, we will move the left pointer as we are currently pointing to a smaller number in the list compared to the right pointer. We will then update our left max as the number we are pointing to is bigger than the current local max. We will then add the difference between the max height and the number to our rain total. In this case, the difference is 0 because we just changed the max height, and of course, the number minus itself is 0. Now we repeat this process on the right. Same idea. The right maximum just changed, so the amount of rainwater we will add to it is 0. We can keep going until the left pointer crosses the right pointer, and in doing so, we will have found the amount of rainwater from each local minimum on both the left and right sides of our map. Okay, and one more example. As you can see, the right pointer and the right maximum never change because 5 is the biggest element in the list. Instead, the left pointer will traverse through the list, and the difference between the left maximum of 4 and each element will be added to the total rainwater. In this case, 9 should be returned. All right, so let's code our solution. We begin by initializing a left and right pointer, as well as a left maximum and a right maximum. We will also initialize water to be 0. Next, we will say that while the left pointer is less than the right pointer, we will perform a check. If the left height is less than the right height, we will increment the left pointer by 1, adjust the max left height as needed, and then add the difference between the left maximum and the new height to our rainwater. Likewise, if the right height is equal to or greater than the left height, we will perform the same procedure for the right. We're going to decrement the right pointer by 1, we can adjust the max right height as needed, and then we can add the difference between the max and the new height to our rainwater. Once this loop terminates, we can then return the rainwater that's been collected. The time complexity of this algorithm is O of n because in every case, we'll need to point to every item in our input list of size n. No extra space is needed, so our space complexity is O of 1. And that's it. You've gone over a respectable assortment of two-pointer problems, so maybe you can study a new concept now? Anyway, enjoy, and we'll see you next time.